Hi, in our earlier video we covered performance tuning of Informatica and categorization of bottlenecks, where we covered target bottlenecks, source bottlenecks, and currently we are at mapping bottlenecks. And in mapping bottlenecks we covered aggregator, joiner transformations, performance enhancement. And next thing is if we have unsorted input for the joiner transformation, then to get a better performance the source should have a very less number of records, and that should be as a master source. And for sorted joiner transformation, if you have a source with fewer duplicates, then there should be a master source. And other thing is, if you have any other tables with huge number of records, then use them as in joiner transformation instead of using them in lookup. And if you have multiple filters on lookup transformations, make sure the most efficient condition we are using as the first. That condition will eliminate more number of records. Nothing but the low level grain we should use as the first thing. And avoid using string functions, as string functions use more resources than comparing non-string functions. Nothing but wherever you use in where class, if you have filters on string functions, it takes some extra time than compared to the filters on integers. And avoid using multiple if conditions, rather optimize the expression. And reduce the number of transformations in the mapping. Nothing but the data will flow through each and every transformation. It always a overhead to have more number of transformations. And calculate once and use many times. Nothing but it's kind of maplets or any other unconnected lookups kind of functions, or any other variables, calculated expressions, calculate once and use many times. And next thing is lookup transformation. So in our lookup, if you have any other unused ports to be neither input nor output, to make generated SQL override as small as possible to cut down the amount of unnecessary caching. And the next thing is nothing but next bottleneck is session bottlenecks. In session bottlenecks, we have few causes for session bottlenecks. One thing is small cache size, low buffer memory, and small commit intervals. Nothing but if the commit interval is very small, very frequently the data will get committed, and it slow down the performance of our session or mapping. So here I will show you the commit interval where we can set it. So in the properties, this is the commit interval that we can change as we required. And we have this is the DTM buffer size auto, and override tracing to normal from none. So the tracing level will tell us the how much log it can store. So let me show you the override property. This is the override tracing. It is currently none. We can change it to normal. And avoid heavy files in FTP location and move them to info server location. It is to easily access the files. Nothing but if the integration server easily access the files, if the files are reside at info server location instead of at some other FTP location. And the last one is system bottlenecks. System bottlenecks is nothing but the amount of CPU that is using for our current particular operation or transaction. So if it is more than 80%, then we might need to change the load that's currently applying, or use a grid to distribute the task to different nodes, where we can distribute the load to different nodes. And other thing is, if the CPU usage is more, we can add more number of processors to split the CPU usage to different processes, so that we can reduce the CPU usage or nothing but CPU load. So these are the main 5 bottlenecks that we can observe in Informatica. So if you look into all these things, the final one that is completely related to the hardware that we are using in our system, and remaining 4 are completely related to Informatica and database. Nothing but the target and source are related to our complete database, the query optimization technologies that we are using and writing and indexes that we are applying, and remaining mapping and session were completely related to Informatica, where we can apply some changes or properties, update the properties, kind of things. And in system bottlenecks, the integration sets also uses the system memory to create cache files for transformations such as aggregator, joiner, lookup, sorter, XML, and rank. So using the work, and we can use our workflow monitor to identify the system bottlenecks. There we can see our integration service properties to see the CPU, memory, and the system, the usages. So here I will show you where we can see these properties. So here majorly we have three things. One is CPU percentage, memory usage, and swap usage. By going to view and select the properties view, this window will appear. In this window, in partition details, you can see the CPU percentage, nothing but the CPU usage, and the CPU seconds, memory usage. So the CPU percentage is nothing but the amount of percentage that CPU includes other external tasks that are currently running on the system, and the memory usage, it includes other external tasks that were currently running on our system. And the last one is swap usage. It is nothing but it's a result of paging due to possible memory leaks or a high number of concurrent tasks. And all these are using nothing but all these are identifying system bottlenecks using workflow monitor, and we can identify these system bottlenecks on our windows in our task manager by going to this task manager. So here we can see the processes, that the each and every process consuming CPU, memory, and the disk, everything, and the performance monitor also. So here for our designer and the monitor, so this is our workflow monitor. There you can see the CPU percentage that is taking, and the memory, the amount of memory that it is taking. So these are all the ways that we can identify system bottlenecks. Thank you.